Welcome to this course on Elements of Mechanical Engineering. My name is D. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this course, we are in the fourth module where we are going to study the machine tools, different machine tools used in manufacturing industry. So let us see the introduction to machine tools and the introduction to lathe machine also. So before going into this topic, we should know what is manufacturing industry and how it affects the engineering field. So in manufacturing industry, we have different fields that are related directly or indirectly to engineering, where we have to produce different types of objects that are made up of metals, non-metals, and etc. So the machine tools, so these machine tools directly relate to the manufacturing industry. So what is manufacturing industry actually? Suppose if I want to build a building, I should need some concrete and iron. Where should I produce this iron? So building concrete is separate thing. And how can I produce this iron bar? So these iron bars, they are extracted from iron ore and they are converted into particular shape. They are melted, they are processed and they are converted into required shape like wire, bar, plate or billet, etc. So depending on the type of application, we can do multiple techniques for processing and converting the shape of the iron or any metal. So this process comes under manufacturing systems. So in mechanical manufacturing systems, we have to deal with multiple operations like starting from casting, which is completely melting the metal and we convert it into required shape by pouring it into a mold cavity. And then we see forging. In forging, we have to heat the metal object up to recrystallization temperature and we have to apply some pressure by beating it with some force. We can change the shape. And then we have some machining process. So what do we do in machining process? In machining processes, we have to actually turn or we can change the dimensions by removing the extra particles. That is, removing the extra material by chipping or by filing. So this is the third method which is used in manufacturing systems. And also we have other processes like we can make the surface very smooth. They are all comes under the precision methods. Okay, so mostly these three are the methods which are used for manufacturing of any object. Depending on the application, we have to go for casting, forging or machining. Now when we want to study what is machining, we have to know what are machine tools. Okay, so the machining is a process in which we have to convert the size and shape of a particular metal object by using other tools. So these tools are made up of high-speed steel, so where they have more strength and toughness when compared to the base metal. Okay, so in machining processes, we have to use these machine tools. Now there are multiple machine tools that are available in industry. So starting from lathe machine, drilling machine, other machines like milling machine, etc. There are multiple machines depending on the application and depending on the type of machining we have to apply on the workpiece. We have to choose a particular machine. So in those machines, let us study the lathe machine first. So lathe machine is a very popular machine where multiple operations can be done on this machine by changing small parameters or by changing small adjustments. We can do lot of applications and lot of processes can be done on this lathe machine. So what are the different applications we can do or what are the topics we are going to study in this module? So we are going to see the lathe principle and then parts of the lathe machine and then operations on the lathe machines like turning, facing, knurling, thread cutting, drilling, taper turning, etc. So these are all the processes these are all the machining processes which can be done on lathe machine. And then, what is a compound slide, swiveling method, specifications of lathe. So these are all the topics we are going to cover when we are going to study the lathe machine. And then we have other type of machines called milling machines. So in that we are going to study the principles of milling machines, types of milling machines, working of a horizontal and a vertical milling machines, milling process, and different milling processes are there: plain milling, end milling, slot milling, angular, form, straddle, and gang milling. So these are all the different types of milling processes, and out of these we are going to study each and every process in order to understand the milling process, which can be done in multiple ways depending on the type of application or the type of condition where the workpiece has to be converted into required shape. Now, let us see the principle of working. Principle of working of a lathe machine. So this is, in this picture we can see, this is a lathe machine outline where we can see multiple parts. There are large number of parts are present in this lathe machine, where each and every part of this machine are useful in some manner. Now, the key parts of this lathe machine are, first one is this bed. So in lathe machine, bed is the major component on which the entire components or all the parts will be standing. Okay, the bed is made up of cast iron. It is very heavy, and on this we can place all the tools and all the machinery, motors, etc. Everything will be placed on this bed only. And upon this bed, we have a moving mechanism, that is straddle. Okay, this is a moving mechanism. This part is moving mechanism where it can be moved with the help of a electric motor. On this we have a headstock. So this headstock is nothing but it is the gearing mechanism where it contains multiple gears to increase or decrease the speed of rotation of the spindle. So the spindle can be speed up or slowed down depending on the type of object or depending on the type of metal we are machining. Okay, so this contains gears which are connected to a electric motor, and then this part is known as the tailstock. So the tailstock is a part where it is used to support the workpieces sometimes, or it is mostly idle. Okay, the tailstock will be used to support the workpiece when it is inserted into the chuck. Okay, now we'll study what is chuck and what is spindle, and everything will be studied clearly. So first one is spindle speed selector. So this device can be used to control spindle speed. What is spindle? Spindle is nothing but the device which is rotating here, which can be rotated clockwise or anti-clockwise depending on the size or depending on the application. Okay, we can control the speed of this spindle by operating this wheel. And then we have forward and reverse mechanism. Here we have a switch directly which can be operated in both forward and backward directions so that it will change the rotation of the spindle. So one direction it will rotate in clockwise, and it is operated reversely. The spindle can be rotated in anti-clockwise. So we can operate this machine in both the directions, both in clockwise and anti-clockwise. So one important disadvantage and advantage of this process of using lathe machine is we have to turn cylindrical or circular objects only, because we have a moving mechanism which can be rotate in clockwise or anti-clockwise. So that is why we can produce only cylindrical or circular shaped objects. Okay, and then here this is forward and reverse, and then we have stop rod which will protect the movement of the spindle depending on the type of application, and then we have feed shaft. Depending on the movement on this feed shaft, we can give feed, like tool is fixed here. In this we have a tool fixed. That means we have a workpiece fixed in this chuck, and we have to put a tool on this tool post. This is tool post. On this tool post, we have to fix a tool which is made up of high speed steel. So this tool is so strong that when it touches the workpiece which is rotating, it will remove the metal on the workpiece. So this process is called chipping, where the chipping process will be continued. When we want to give feed, that means when we want to move it forward, we have to give feed. So giving feed is nothing but removing more material from the rotating workpiece. So when we want to give feed means there are two types of feeds. One is moving forward and another one is moving along the workpiece length. Okay. Suppose if this is a cylindrical workpiece. So this is a cylindrical workpiece. So on this, we can remove metal in this direction so that we can decrease the diameter of this cylindrical workpiece. If we keep the tool only at this point, it will remove only a particular area. Now, if you want to remove the material through the entire length of this cylindrical rod. So this is length and this is diameter. So we want to give feed. So while giving feed, we can remove the diameter through the length of the body. Okay, we can decrease the diameter of the entire cross section by giving feed. Okay, so that is called feed. And then we have longitudinal feed lever. We have a lever which can be operated so that we can change the longitudinal feed also. And then we have carriage hand wheel. So this carriage hand wheel is operated to move the tool post towards right side or left side. Okay, and then other parts we have like a hexagon turret, that is the tail stock is fixed on this, and then we have ram which is a solid block which is fixed to the tail stock, and then we have turret stops, and the turret stop is nothing but it is used to hold the mechanism, it is used to hold the workpiece when drilling operations are done. And then we have turnstile which is only present in capstan lathe machine. And then we have feed selectors. So these are all the different machine parts which combinedly work together to make machining on a workpiece possible. Okay, so the study of lathe machine in a slide like this is very hard. We have to experience the lathe machine practically so that we will get more knowledge about each and every part of the machine. Now let us study what is the principle of working of this chuck. So what is chuck? So this chuck is nothing but it is the device which is connected to the spindle of the body, spindle of the headstock. So what is the function of this? So it has a simple function that it has to rotate when it is made to rotate along with the electric motor, and also it has to withhold the workpiece. So there are two functions. First function is to rotate and the second function is to hold the workpiece tightly. So that is the key thing that is done by this machine. Okay, this part contains different parts like multi-tooth cutter, and then we have drill, tool for turning or boring, reamer, individual motors. Okay, so different types of parts are connected to this in order to do multiple operations. Okay. So depending on the type of application, we have to use particular tool and we have to operate it so that we can get the different or required shape. Now let us see the basic parts of a lathe machine. First one is bed. The bed supports all major components of the lathe machine. Beds have a large mass and are built rigidly, usually from gear or nodular cast iron. So most of the beds of the lathe machines are made up of grey cast iron, and this bed is the major component in lathe machine where it has to hold or it has to carry all the moving parts or all the parts of the lathe machine itself. So it is made very sturdy and it is very heavy in weight, and it is mostly made up of grey or nodular cast iron. And then we have second part, that is carriage. So the carriage or carriage assembly will slide along with the bed so that it contains the assembly of the cross slide, tool post, apron, etc. So all the moving mechanism. So the bed is there. On this bed we have this carriage which can move in this direction or in this direction. So on this we can keep tool post, this moving mechanism, feed giving mechanism, etc. Everything will be placed on this carriage only. And then we have headstock. On the left side we have a headstock in which we have multiple gearing system and also the spindle or the chuck, etc. will be connected to this only. Okay, this is chuck. In this we can place workpiece. So this is workpiece. So this is spindle. So every moving part that is placed in the headstock only. Okay, the headstock is fixed to the bed and is equipped with motors, pulleys, V-belts that supply power to the spindle at various rotational speeds. Okay, now another part is there, tailstock. So what is the function of this tailstock? The tailstock, which can slide along the ways and be clamped at any position, supports the other end of the workpiece. Suppose in this figure, I have drawn that there is a workpiece which is attached to this. There is a workpiece which is attached to the spindle. This is workpiece. So what happens if the workpiece is very long? It may wobble around when it is rotating. So we know that the spindle will be rotating in clockwise or anti-clockwise directions. So when it is rotating, we have to keep the tool here. We have to keep the tool here in order to remove material from the workpiece. So if the length is very large, so the length of this workpiece is more, we have to support this with the help of the tailstock. So the tailstock is a device which is attached here, on which we have a supporting tool. So this supporting tool will withstand, or it will hold the workpiece so that it will not move in cross direction. It will completely rotate in a pure rotation. Okay, so that is the function of this tailstock. And then we have feed rod and lead screw. So the feed rod is powered by a set of gears through the headstock. So what is the function of this feed rod? It is used to give the feed when the object is being machined. Okay, the rod rotates during the lathe operation and provides movement to the carriage and the cross slide by means of gears. Okay, by connecting different gears to the rotating electric motor, we can make the electric motor or the lead screw can be made to rotate. Okay, so then what happens? And it provides movement to the carriage and cross slide by means of gears, a friction clutch and a keyway along with the length of the rod. So we have to connect all these devices in order to make the working of this machine properly. Okay, friction clutch is there, keyway is there, etc. Everything has to be connected to the lead screw in order to make it move easily. So the movement of this lead screw, I'll show you where this lead screw is there. So at this point, the lead screw will be there. The main function of this lead screw is it is mostly used in the thread cutting operation. We'll see in the coming classes how is thread cutting done with the help of this lead screw. Now, these are the important parts of a lathe machine. There are 5 important parts. The first one is bed, second one is carriage, and then headstock, and then we have tailstock and feed rod, lead screw. So these are the important parts of any lathe machine. Along with this, we have some other parts which can be modified or added according to the need of the machine. And then we should know what are the lathe specifications, depending on which we can select a particular lathe machine. And depending on the type of application, we have to choose a particular machine. So for that, we need some specifications or standard values, out of which we have to select from a catalog. So at swing, the maximum diameter of the workpiece that can be machined. So whenever we want to do some machining operation on a lathe machine, we have to choose a machine which is suitable for the required diameter. If the diameter is more, the diameter of the workpiece is more than the actual diameter that can be fitted into the lathe machine, we cannot do the operation. We have to go for a bigger machine. Okay, so every chuck, we have seen in the previous slide, the chuck will be having a chuck jaws. Inside these jaws, we have to fix the workpiece. So this is workpiece. So the diameter of the workpiece should be always less than the chuck diameter. If the chuck diameter is less, we have to go for bigger lathe machine. And then we have second one, the maximum distance between the headstock and the tailstock centers. We have seen in the previous slides, we have tailstock which is used to support the workpiece when the length of the workpiece is more. So if the workpiece is larger than the actual length of the bed, we have to go for a bigger machine. Or if the machine is very small, we cannot machine the workpiece, because the workpiece, when it is fitted into the headstock, it will be touching the tailstock. It should not be touching the tailstock. We have to take the support if it is very long. Even though it is longer than the tailstock itself, we cannot machine it on the particular machine. And then the length of the bed. The length of the bed also plays an important role when it is when we are selecting a lathe machine for doing a particular machining operations. Because if the length of the bed is smaller than the workpiece, we cannot machine. And then let us see what are the some operations which can be done on the lathe machine. The first one is turning operation. So turning operation is nothing but we have to take a cylindrical diameter cylindrical workpiece, where we will do turning operation in order to remove the material. We have to reduce the diameter of this workpiece. So to do that, we have to do the operation called turning operation. Initially the diameter is D. I have to decrease the diameter to D minus X. So this is the final diameter. Initial diameter is D. So in order to do this, I have to remove the material from this cylindrical rod throughout the length. Suppose the length of this workpiece is L. I have to remove the diameter, that is extra material, throughout the length. So I will simply place this workpiece or the cylinder into the headstock, and I will switch on the motor so that it will rotate in clockwise or anti-clockwise direction. Okay, and I will keep the tool here. I will place the tool here so that it will remove the material. Okay, whenever the material is removed here, I have to move it slowly towards the length. So this is called feed giving. So whenever I move the tool, it will remove the material through the entire length of the metallic rod. Okay, so see here, the tool is attached to the tool post and the workpiece is attached in the chuck. Okay, so the workpiece should be kept in the chuck and the tool post will hold the tool. And then long slender parts must be supported by the tailstock. If the workpiece is very long, we have to take the support of tailstock. And then the cutting tool removes material by traveling along the bed. So I have to move this in this direction. So this is called feed. So along the length of the bed, we have to move. Okay, so that we can remove the material from the workpiece. And then a right hand tool travels towards the headstock and a left hand tool travels toward the tailstock. So depending on the rotation of the headstock, we have to move the tool in particular direction. So a right hand tool, it will move towards the headstock. So I will move the tool towards the headstock from right to left. So that is called right hand tool. If the tool is left hand tool, we have to move the tool from left hand to the, that is towards the tailstock we have to move. So this will be more practical when we see them in the laboratory. And then facing operations are done by moving the tool radially with the cross slide and also clamping the carriage for better dimensional accuracy. We have to clamp the carriage at a fixed position so that we can give feed accurately, and we have to remove the material so properly so that the diameter of the workpiece is uniform throughout the length. Okay, so this is turning operation. So turning operation is one of the easiest and first operation that can be done for a fresher who does not know how to work on a lathe machine. Okay, and then we have different turning process in different machines. Okay, we have different lathe machines depending on their rate of speed on which the turning process can be done on them. They are shown here. So in engine lathe, the rate of doing turning process is very low to low. Okay, in tracer lathe, there is low to medium, turret lathe low to medium, and computer controlled lathe also low to medium. And then we have single spindle chuckers and then multiple spindle chuckers, where we have single spindle chucker is nothing but it is a single spindle which is attached to the headstock, where we can get medium to high speeds of the turning process. And when we have multiple spindles which are attached to the headstock, we can do this process very fastly. We can remove more metal in lesser time. And then different operations are there like boring, drilling, milling, planing. So depending on this type of operations, we can see those speeds. low to medium, very low, etc. So depending on the type of machining process we are doing, we have to see the rate of speed. So depending, so in all this, in this multiple spindle checkers, the turning process can be done very fastly. The rate of removing the material in this process is very high. Okay, and then let us see some design considerations which are to be considered while doing the turning operations. So the first one is parts should be designed so that they can be fixed and clamped easily into the work holding device. So this is the first and foremost point should be kept in mind while using a lathe machine for turning operation. If I want to do turning operation for a workpiece of some diameter, the diameter of the workpiece should be less than the diameter of the spindle so that it will be inserted into the headstock easily. Otherwise, I cannot insert it and I cannot do this machining process on a particular lathe machine. And then the dimensional accuracy and the surface finish specified should be as wide as permissible for the part to still function properly. So this is second point where the dimensional accuracy and surface finish are also should be kept in mind while selecting a particular lathe machine for the particular process, turning process. And then we have sharp corners, tapers, steps and major dimensional variations in the part should be avoided. So sharp corners should not be there. Taper turnings should not be there. It should be done by a skilled person. Step turning should not be there. This will increase the it will increase the stress concentration in the body. So taper is good. Step turning is not good because it will increase the stress concentration at particular areas. And then major dimensional variations also should be avoided because we are doing the turning process on a rotating machine. That means a rotating machine called lathe machine is used. We have to do turning process and we have to keep the turning process as simple as possible because we can do this turning process easily when it is a cylindrical object. If we make the design more complicated, we cannot use the lathe machine. We have to go for other machines like CNC machines which will make or prepare the object depending on the particular design. And then blanks to be machined should be as close to as final dimensions as possible. So whenever we are machining a workpiece, this workpiece should be machined as close as to the final dimensions. And then parts should be designed so that cutting tools can travel across the workpiece without obstruction. So whenever the workpiece has to travel along the length of the workpiece should be designed or the design should be in a manner where the workpiece or the tool which is moving along the length of the workpiece, it should be easily movable. There should not be no obstructions. Okay. And then design features should be such that commercially available standard cutting tools, inserts and tool holders can be used. This is a very important point where you have to design your workpiece or an object which is to be machined on a lathe machine. So you have to follow standards. Otherwise, you cannot find the tools, cutting tools, inserts, tool holders cannot be found. Okay, you have to do all these processes. The design can be done only within the following the standards of the industry. Otherwise, the cutting tools may not be suitable for your workpiece metal, or inserts, tool holders may not be suitable for your workpiece design. And then we have workpiece materials should be selected for their machinability as much as possible. So any metal that is selected for your particular workpiece, so the metal should be having more machinability. We have seen in the previous lectures what is machinability also. So depending on the material, machinability changes. So some of the guidelines for doing the turning operation, you have to minimize tool overhanging. That means you have to take the support of tailstock if the object is very long, or if it is very small, you have to insert into the headstock so tightly so that it should not overhang, because it will produce a uneven turning process. And then support the workpiece rigidly. So you have to support the workpiece rigidly in the headstock if it is very small in length. If it is very long, you have to take the support of the tailstock. Use machine tools with high stiffness and high damping capacity. So the machine tools which are selected should be having high stiffness and high damping capacity. When tools begin to vibrate and chatter, modify one or more of the process parameters such as tool geometry, cutting speed, feed rate, depth of cut, and use of cutting fluid. So whenever we are doing the turning operation, we may see some vibrations in the tool. So at that time, we have to stop the process, or we have to change some parameters like tool geometry has to be changed, or you have to reduce the cutting speed, or you have to change the feed rate. You have to give the feed slowly, and then we can change the depth of cut. Okay, and almost in all applications, you have to use cutting fluid because we are machining a metal with another metal which produces large amount of heat. We have to produce, we have to use the cutting fluid so that it will cool the workpiece and the tool. So these are the guidelines for turning operations. So that is all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.